So this video will be going over more trigonometric identities and formulas, such as the double angle, half angle, and power reducing formulas, and more of those of the like. So here we have two examples with cosine cubed x, and then we have another one with cosine 112.5 degrees. So this first question is asking us to simplify cosine cubed x into single powers of cosine x. So we see this cubed here, and I instantly think to mind our power reducing formulas because that will help us simplify this into single powers of cosine, right? So there are no formulas of cosine cubed x, however, there are only formulas of cosine squared x. So what we're going to want to do is simplify this into cosine x times cosine squared x. We're going to break it apart essentially, but there's still the multiplication, and if you do multiply these two together, they still go back up to that original cosine cubed x. So it's all fair. It's all fair. Now that we have a cosine squared x, we can use our power reducing formula. Cosine squared x equals 1 plus cosine 2x over 2. So we essentially just replace that cosine squared x with this thing here, with this, big 1 plus cosine 2x over 2 expression right here. Cannot forget the cosine x still on the outside being multiplied to it, right? So we essentially first broke down to the two separate parts, and then used the power reducing formula to turn this into a single power of cosine. Now the next step will be to the next step I've done is I multiplied it out. So I multiplied out cosine x times 1 and then cosine x times this other thing here, right? We're using the distributive property. So cosine x times 1 is just cosine x, which is right there. You might be noticing this, and you might be a little confused, like what is going on here? Well, that comes from the second part, right? Cosine x times cosine 2x. But the problem is you cannot multiply these two together and then just make it like cosine squared 2x. That doesn't work because this is cosine x. This is cosine 2x. This 2 right here makes it so that way you cannot multiply these together, as this is cosine of angle x while this is cosine of angle 2x. It's two separate angles. So you cannot multiply them together to get a single term. We're just going to leave it expanded like this. So we're just going to leave it cosine x times cosine 2x. That's a multiplication sign, by the way. So we're just going to leave it like that. I mean, you could imagine, parentheses if you want. But now what we're going to do, and this is all over 2 here, as you know, right? This is all over 2. We're then going to factor out this 2 just so that way we don't have fractions anymore. It's going to be nice and clean here. Cosine x plus cosine x times cosine 2x. Now the next formula we're going to use here is the product to sum formula to get rid of this multiplication and perhaps simplify it into addition. So, because as you can see, this is a multiplication. The formula is 1/2 cosine u minus v plus cosine u plus v. And you might be wondering, and I was confused for this for a while, what are the u's and v's when the angles here are the same? There's not x and y. This is just both x and x. So what are they talking about u and v, right? The u and v are actually referring to the coefficients. So the coefficient here is just 1, right? Because there's nothing there, so it's implied 1. It's cosine 1x, isn't it? This is just cosine 1x. That's supposed to be a 1. This is cosine 2x. So the u here is actually 1, and the v here is actually 2. 2 coming from that coefficient there, and the 1 coming from the implied coefficient there, which isn't directly written. Okay, so we know this. Actually, I'm going to leave that there. So we know this. Now what is it telling us? So the first part is u minus v. So that'll be 1 minus 2. Can't forget the 1/2 on the outside. So when we come back here to simplify it, it's 1/2 still from the outside there. Cosine x still from there. Plus, and then now we're breaking this up, right? Into 1/2, that is from that 1/2. cosine, and then we have to do u minus v. So do we do 1 minus 2? One minus 2 we know is -1, so it's going to be cosine negative x. Then it's, what is it here? U plus v. So then we're going to do 1 plus 2, which gets us 3. So now we have this. So we were able to break apart this multiplication into this sum here. Now also, as you know, cosine negative x is actually equal to cosine x. Those are the same. Cosine x is the same thing as cosine negative x. Sorry for the terrible handwriting, but you get the point. So that means that we can now just replace this negative x with just a regular x to make it easier for us. And we're also going to factor out in the same step. I guess we're going to do two things at once. We're going to change this negative x to a positive x because those are actually equal to each other. Cosine x is equal to cosine negative x. That is a rule. So, and then we're also going to factor out this 1/2 here. Again, we're going to take out another 1/2, factor it out. So now, if we take out this 1/2 here, if we factor it out, then it's going to be 1/2 times 1/2, which would be then, 1/4. But if you notice, this went from cosine x to 2 cosine x. And why? Because originally at the top, it was cosine x over 2. Okay? Here, when we factored out that 2, that's still cosine x over 2 if you were to multiply it back out. But if you were to leave this as cosine x, then it would be cosine x over 4, which is wrong. So we actually have to multiply it by 2, so that way it stays equal. Because now it's 2 cosine x over 4. If you were to multiply this back out, right, it would be 2 cosine x over 4, which is the same thing as, these would cut to become 1/2. 2 over 4 is the same thing as 1/2, right? So then it would stay equal. So you do have to multiply the rest of your terms by this number here, actually. So whatever stays in the parentheses will stay the same, however, because that's the thing you're taking the 1/2 from. The 1/2 was being multiplied here. Now we're taking it out here. The reason we have to multiply this is because it was never multiplied by that 1/2. So these terms are now cosine x because we replaced that negative x. And this cosine 3x, all good. And now I guess the final step is we leave this 1/4 out, right? We factored it out. There's an x here and an x here, so since those are using the same angle, we can actually add them together. So 2 cosine x plus cosine x will be 3 cosine x. You cannot add this cosine 3x though because of that coefficient 3 before the angle. As you know, it's now essentially saying cosine of 3x as the angle. This is saying cosine of x angle is saying cosine of 3x angle. So they're separate and you cannot add them. This is your answer, actually. This is your completed answer. We've split it apart as much as possible using the power reducing formulas and also the product to sum formula. I don't think there are any other formulas you could use here, and it is in single powers of cosine. So that is our job finished. Now the next problem is cosine 112.5 degrees, right there. Now, what we're going to do is we're going to change this 112.5 degrees because that is not on the unit circle, right? We cannot find that, whatever, and we're not trying to use a calculator. So we're going to change this into an angle we do know, 225, that is on the unit circle, over 2. 225 divided by 2 is 112.5. So essentially, we're just going to replace this with this expression, and then we're going to use our half angle formulas because this is a 2, right? This is the same thing as 1/2 times this. So we're going to be using the half angle formulas, which involve those, square roots. So now we use the formula. So now for cosine, that would be, it's actually plus or minus root 1 minus cosine u, u being this angle right here, all over 2. So we do that. cosine u. So now u is 225 degrees. So what's cosine of 225 degrees? Well, that is actually that is root 2 over 2. And it's actually negative root 2 over 2. But then these two negatives, negative becomes a positive here. So then, yeah, that just becomes a positive under the root. So yeah, and that's again all over 2. That stays the same there. And then we move on to the next step. So the next step will be to try and add these two terms, this 1 and this root 2 over 2. How could we add them? Well, the denominators are not the same, so we're going to make the denominators the same in order to add them. So 1 is the same thing as 2 over 2. So now that it's 2 over 2, again, all over 2, I'm doing this step by step, showing you every single thing we're doing here. Then we can now add them, right? Because now that these denominators are the same, we can add the numerators. So now this will be 2 plus root 2 over 2, and then over 2 again. Now this over 2 thing, you could imagine this as 2 plus root 2 over 2 times 1/2 here, right? So then that would be 2 plus root 2 over 4. And then we get our answer here. What I didn't write here, however, is that throughout this entire problem, it will be plus or minus. So this is in reality plus or minus. Now, how do you decide whether it is plus or minus? Well, you have to look at the sine, or whatever. In this case, it was cosine, correct? So you have to look at cosine of that angle and see